So looking at exponential functions, we're going to look at a few of them in detail and get some general characteristics of them based out of that. We're going to start by looking at y equals 2 to the power of x, really. So we'll look at the graphing calculator. We'll graph that out. So y equals 2 to the exponent of x. We'll graph it, and we'll see that it looks like this. As best as we can, we're going to sketch that on the graph itself. Now, the way that the calculator graphs it out at the left side, it looks like it ends, but it actually doesn't. It continues going on. All the way to the left side. So the shape of that graph, that would be an exponential graph. The domain and range, well, the domain of all exponential functions is any real number. And the range of all exponential functions is y is greater than 0. It's not greater than or equal to 0 because that graph goes just to the y-axis, sorry, just to the x-axis, never actually touches it. The y-intercept is always at 1. The x-intercept does not exist. Because the function is y greater than 0, it never actually touches the x-axis. The equation of the horizontal asymptote, that is the x-axis, that would be y equals 0. And those four characteristics in question 2 will be the same for all exponential functions. So now question 3, select two different values. Just for example, we'll take y equals 3 to the x and y equals 5 to the x. Go back to the graphing calculator. You can clear out the first function, put in 3 to the power of x, graph it out. The shape is very similar, however, at the right side it gets steeper much faster. If we do the same thing with 5 to the power of x, and we'll see again the shape is basically the same, but it gets steeper even faster still. Now, it's not very visible on the graphing calculator or on the graphs we have, but there is a specific point that all of these functions go through. All of these functions will go through 0, 1. As well, there's a specific point to each graph that the graph will go through. So this top one will go through 1, 2. Y equals 3 to the x will go through 1, 3. And as you may have guessed by now, y equals 5 to the x goes through 1, 5. If we take that same concept and we pick two values for c that are between 0 and 1, we'll say y equals 0.75 to the x and y equals 0.4 to the x. Again, I'm just picking numbers randomly. Graph those out. We see that the shape is basically the same, except it has been inverted. It's going the other way. Repeat with 0.4 to the x. And we have a steeper graph, but again, it's the same orientation as 0.75 to the x. All of these graphs will go through 0, 1.
and they will also go through 1c, c being whatever the base is. So 0.75 to the x will go through 1, 0.75, and 0.4 to the x will also go through 1, 0.4.